University. He is teaching at Indian Institute of Technology Madras, Indian Institute of Technology Kharagpur, adjunct faculty at IIT Bhubaneswar, adjunct faculty Chettinad University and Amrita Vishwa Vidyapeetham, Vajira Tech, India. Professor of Practice at VIT University, Chennai, visiting professor at Tamil Nadu, Dr. Ambedkar Law University, member of Planning Board, uh, and past Senate member of State University, CAS Anna University, member of Research Advisory Board of many colleges, Sona College of Technology, member Board of Management and Research Advisory Council of AMET Maritime University, Administrative Committee member Sai Ram Engineering College and Syllabus Committee SRM University, member of International Affairs Division of Anna University. He served in various capacities in the United Nations Organization in UNESCO, IOC Paris, WMO Geneva, and United Nations Environment Program UNEF Nairobi. He visited Arctic installed India's underwear observatory. He has traveled to 40 countries and delivered lectures in many universities in USA. He established a real-time data reception center with the instruments deployed at sea for monitoring cyclone, tsunami, and developed various technologies and conducted student competitions. Guinness World Record with school students closely and works with the school and college students in monitoring them. He was instrumental in organizing planting of 20,000 coconut trees after Gaja cyclone in Tamil Nadu. He has to his credit 180 papers in 82 journals, out of which 3 papers were published in the Nature Journal. 10 patents filed, 4 awarded. Guided 6 PhD scholars and reviewed 20 PhD theses as an examiner, 500 invited lectures in seminars, and members of editorial board of 3 international journals, and edited 3 books and 10 products technology transferred to industry associated with technical societies such as MTS, IEEE, IEI, and NACE, and many more. So today, Dr. R. Venkatesan will grace us with his presence and share his unparalleled expertise on advances in computing for ocean environments. We are privileged to learn from his wealth of experience, and I have no doubt that his insights will leave on indelible impression on each and every one of us. Without further ado, please join me in warmly welcoming the remarkable Dr. R. Venkatesan as our esteemed resource person for the today's faculty development program. Welcome you, sir.
Thank you. Thank you very much. Can I upload my file?
Yes, sir.
Is it visible? Is it visible? Is it visible to all of you? Okay, not that. Okay. I should choose screen, no? Correct? Screen, then I have made it full screen, this particular one. You should be able to see now. No? Fine. Good afternoon to everyone, and today I'll be talking about these advances in computing for ocean environment. And at the outset, I thank Vice Chancellor JNTU GV Vijayanagaram and my good friend who has requested me to make this presentation and also thank our Ministry of Earth Sciences and Director NCCR, where I am currently employed, and Dr. Jayasuma, who had approached me to make this to happen today. And also I was helped by Dr. Saurasil, my co-investigated many programs from IIT Bhubaneswar, and my colleague Mr. Ramsundaram. And thanks to every one of you. And I'll be taking all of you to a newer discipline called ocean, and atmospheric science partly linked to that, and how these computing facilities are required, and how this expertise from all of you would be useful. And you are the esteemed faculty of various institutions. So I thought a knowledge what I can share with you all would be very beneficial to you to share with many more students with whom you will be addressing to that. So even though this topic is on computer science, I thought there are some discipline which basically you should know before getting into the actual topic. So what I thought we'll talk about a little bit on ocean, in before that on ocean engineering and science and engineering, on emerging technologies and how the ocean is related on sustainable development. That's what we are here. And a little bit on policy. This is a full course I teach for one semester in IIT Madras, but I'm not covering. I'm just giving you glimpses of that. At least you should be aware what are the policy. And I will also be giving you some information about free data sets on ocean where they are available. And then basically we'll talk about introduction to ocean models and AI and ML and case studies. And added to that, I'll also talk about IoT and robotics part of it, where we have developed instruments and deployed at sea. So it's a collection of all. I was told by Dr. Jayasuma that we have discipline from mechanical, including computer science and many other discipline. I look forward to have you open-minded to listen to what I'm talking, and look forward to have a more discussion in the end where I can get connected to individual discipline where you're all present here. And this is to begin with. The first portion will be on ocean engineering and emerging technology. How currently, even though the ocean engineering was slower to pick up compared to many other terrestrial-based technology, however, now advancement is taking place on usage of AI and ML and IoT, deep learning, and NLP and blockchain approach and big data. And these are all cloud computing already we are doing. And these are all something which I thought I will share with you. To begin with, it is a very complex discipline, ocean engineering, if you talk about it. Even though there are institutions offering specialized course in undergraduate, however, many of them from the civil engineering, mechanical engineering disciplines, even computer science, they switch over to ocean engineering. And today, many mechanical engineers or civil engineers are working abroad where they are leading professor, because the fluid dynamics or fluid mechanics, what we study in both civil and mechanical, is similar to what we are doing in atmosphere and ocean. Now, there is increasing demand for sustainable energy and resources. Again, ocean engineering plays a major role. With all these things, now we need to consider how best the AI and ML and the emerging technology, how best this can be used for such applications, including on virtual reality. Ocean is such a condition where it is difficult to approach. So we are looking for simulation where the simulated aspects can be brought into the lab. The design of robotics could be possible in the lab, and that could be experimented and tested at sea. Now, in the case of AI and ML, basically we started using, in fact, there are many publications have come on ocean data. I'll be presenting about our work on how ocean data could be useful. Most of the data sets in ocean, they come from satellite imagery and also in-situ observation from various tools. They provide real-time data or near real-time transmitted data. So now to use this conventional method to advanced tools, basically oceanographers, they try to use the old technique. They are yet to come to the real-time field. But however, now this field is changing. In the case of autonomous vehicle, these are all underwater robots. Again, there is a usage of AI and ML for controlling this so that it can go underwater to a prescribed location in a predefined path. And again, this complexity involve how in an ocean environment these tools can move over there and how better control is possible. So we need to develop a lot of algorithm based systems where that should work. So we need more expertise like you people to get involved in such an activity so that more and more energy efficient underwater equipment are developed and deployed at sea. And IoT and ocean engineering is has revolutionized where when we talk about integrating ocean sensors, communication devices, and software systems. Many of the systems which are deployed at sea, there is a definite crunch of power systems. As long as it is on the surface, we may have solar based, but once they dived into the underwater, we depend on primary or secondary battery, lithium based battery. Again, if you have an IoT based system, there is a lesser power consumption. We can make a smart sensor which can program in such a way that at particular time switches on and off. So I'll be sharing some of the work what we have done, and what I'm sharing with you will be all equipment which are deployed at sea, worked at sea, and also we have transferred the technology to the industry. It's not the one theoretical based discussion we'll have, and how our IoT has enabled us to interfacing the both analog and digital sensors for such applications, including for tsunamis and cyclones. And they are really useful, and the technology is improving globally, and there will be more requirement for such work. Deep learning and NLP is another interesting topic which is really emerging, and the users started using in different applications, basically in abroad, where one of the application is on acoustic data. Acoustic data is measurement of acoustic signal that has been emitted by the animals or by the instruments or equipment or moving ship. Now, by analyzing this, there are two aspects. One is for the strategic applications, when the naval requirement, when you want to have a surveillance part of it or unwanted ship or submarine moving over there, we need this acoustic signature. When you get an acoustic signature from different sources, that need to be analyzed, where deep learning technique is really useful to fine tune that, because ocean is so calm, the disturbance what we find or the acoustic signal what we find may be very low, or it may not be possible for us to detect. But deep learning and NLP is they started using it. I will also be sharing some information where we have deployed this transducer at sea and we collected information. And also it's useful for understanding of the ocean, particularly on the conservation aspect. Where are the various biodiversity exist takes place, because different animals produce different type of sound, and we too have recorded. I had a publication earlier how the animal called lobster, which produces noise, and they use a carapace or a shell on the surface. Once in 45 days, the carapace goes out. In that study, we found how the animal noise is differing when the carapace is out, so that it is not allowing any predator to come and attack. So these are all some information which we need to learn from these marine animals using this acoustic data. Again, this deep learning technique would be useful. And blockchain and big data, if you look at it, the security and management of the ocean data is a primary important for us. Many of the systems what we deploy at sea, we have a platform encryption where the complete thing is encrypted. Even the platform is caught by somebody else or some other bad elements, they won't be able to download the data because encryption and decryption is done by us. That was one experience when I had gone to Ministry of Home Affairs to get the approval for using a Iridium satellite communication. This was precisely asked by various experts at Navy, and we could demonstrate and get the approval. So that is very important. The security aspect, where the data should be really protected, and only we should be able to receive, not anybody else tampering over there. So the data analytics is improving, and usage of blockchain approach and the big data will be really useful for us to proceed, including various data sets come from satellites. As you know that more and more satellites are being launched. Even India, we have recently launched ocean data. But how do you analyze that? So many imageries are coming at times. The condition of usage or availability of space, we may not use it. However, the big data approach could be useful for us to proceed in the direction, because the ocean environment is complex. You have waves, you have currents, and these diversified variables that need to be used. Now, cloud computing and cybersecurity, Python, R, edge computing, these are all various applications you'll find it, including AR and VR, where I've seen recently the students started using, in the case of ship design, how the virtual reality could be used in the ship maneuvering part of it, that could be simulated in the laboratory conditions. This I have seen when I visited Canada. They were trying to simulate, because Testing at the marine conditions is always expensive and complex, and Python and R programming languages are being used. Even we are requesting the oceanographers to switch over to that, so that the data transfer or data availability data will be useful by anybody else. Now it's confined to few who are able to have their own code, and they may have a restriction to that. So when you want to open up the data by anybody else, the Python and R would play a major role. And when you talk about Python language for ocean modeling applications, that is really being thought about it. Now there are tools which has come, and GA is one part where already excellent support the Python is providing for GIS application. Image processing, that's another interesting part. I have given some data sets to some students to work on it. We had imageries from the ocean where there are birds and animals which are come over there that should be captured on a real-time basis, and also moving ships and boats. So the image processing technique really it is important. Last year, part of one conference I organized, I used to conduct many student competition. Now also I have announced, which I have circulated. You encourage your student to talk about coastal imageries. Anybody interested, they can mail it to me. In this case, on image processing from the satellite imagery, where the ship is moving from the ship wake one has identified. We got the data from ISRO, from SAC, Space Application Center, and we had requested the student to form a team. They have done a very good job of continuously 4 hours. They have to log in and work on it. So these are all applications of image processing that is really useful for us. Our language, yes, for environmental impact assessment that is being done for any of the coastal or ocean application project, they have to go for and do environmental impact assessment. That assessment could be done for even including for offshore wind farm. Even India, we have opened up offshore wind farms. Sooner you'll find wind farms in 2 locations of Gujarat and of Tamil Nadu near Ramanathapuram. And again, for that, this will be useful. Another important thing which is developed now is marine spatial planning. Like you have a planning on the land, there has to be a planning in this in the marine side also, where there are activities related to port, where there are activities related to fisheries, and where there are wind farm. Many of them need to be defined. The institute where I'm working, NCCR, they have done a very important study with the Norwegian collaboration for Lakshadweep. Again, our language could be used for this application. Again, time series data analysis will be very handy. And these are all some applications. It is not fully developed yet. Maybe some of you can start thinking and providing these data sets to students, and they can start thinking about that. So MSP and EIA, as well as the time series data sets, these are all some interesting aspects where our language could be useful. Edge computing in another part, I thought that will be useful to you, where we have predictive maintenance and real-time data processing. Even during my service, we have a data reception center, and that is one of the advanced level. Anywhere else in the world we have real-time 24/7, including COVID, the data reception was possible. So how do you do the preventive maintenance? That is really useful, and we do have our own advanced computing facility, supercomputing facility for such analysis in Hyderabad, in INCOIS, as well as in Pune, IIT in Pune and IMD in Delhi, and another system institute in SMRWF in Noida. So for all this application, for such purpose, the edge computing will be really useful. So modern oceanographic science is improving. Not like earlier, about 20-25 years ago, it was different. Only ship-based measurements were there, and the Fortran-based programming languages are used. Now the marine science has really improved a lot, and various resources and datasets are available. Data sharing is possible now. Not only shipborne, autonomous vehicles are there. They collect data and transmit, and satellite data sets are there. So it will become computationally intensive, and also an increased pressure. There will be more of interdisciplinary approach. It is not that physical oceanography, like temperature, density, pressure. There has to be chemical and biological parameter also need to be linked. In addition to that, and it was told in my introduction, I am also working for World Meteorological Organization, which is linked to all the meteorological services all over the world, and also the climate services. Currently, I'm a chairman of the Capacity Development Committee, part of one activity. Earlier, I was a vice chair for one of the subgroup called SGOS. I was also part of another group which is really working on. Today, we have computing facility for even atmospheric measurements. NCMRWF is one of the important thing in UK as well as in Europe and the US and NOAA. They all have got computing facility. We had group of experts. I could join and support them. Next by 2030, today you have 1.5 exascale computing facility. Do we need more than that? Do we need speed or, or storage? This we approached many modelers who work on this field and the expert. They have provided information to us. And also when you talk about the data formatting, that is very important for us. Currently, most of these meteorological data sets are transmitted in GTS format, that is Global Telecommunication Services. Now, that is again confined to only the institute and the authorized agency like in India, IMD only can do that. Now, Open GTS, we are working on it. When that comes through, what type of formats are there, how that can be useful. So we call it as a fair, findable, accessible, and readable. That is a level of data sets we are looking. We call fair data sets. So when all these things are there, the computing facility need to be improved, and also the cloud computing where one can access somewhere else and start using that. Yeah, here comes the importance of cloud computing. Now we know very well today we talk about Google Doc, even today's discussion, we all depend on cloud computing. And again, in the oceanographic applications, when you run a model, it's not possible for everyone to have their own storage or access facility. So here comes the cloud computing really helpful for us. And really, it's a boon for such data intensive activity to find a solution. At times, even to run a model, it takes about 4 to 5 days. But however, the prediction need to be faster. So the cloud computing is another aspect I thought I will appraise you where advancement is taking place, and you can read that I've got a lot of text, and there are also policy issues and attribution and traceability aspect. That's all need to be addressed when you talk about that. Of course, still there are bureaucratic approach. I was talking to some professors in USA. The funding agency won't allow you to pay for such cloud computing charges, but still long way to go. But there are I have just listed here how today's world without cloud computing we don't exist. Day to day we are using it, and that is really helping us. Similar like that for such data storage and computing for oceanographic and meteorological or atmospheric studies, I'm sure that days to come it will be very helpful. Now coming back to ocean. So some of you might be in Vizag or you have seen ocean and you've seen Bay of Bengal. And I'm just trying to give you some information which may be sometime new to you or you may be aware of that. This is a one ocean we call it. The Pacific is completely covered. This particular picture can tell you how the 70% of the Earth is covered by ocean and balance 30% we live. Out of that, we talk about various aspects and how this ocean influences our own living. That is very important. The air, what we breathe, the water, what we drink, the environmental conditions or the climate what we live in all depends on the ocean. And also it's often said that the amount of carbon dioxide liberated by the transport sector is absorbed by the ocean. Ocean comprises of or consists of phytoplankton. These are all planktonic animals. They absorb this carbon. And another big topic is about storage, carbon storage and carbon sequestration, how the ocean could be useful to that. So these are a larger level discussion to take place related to ocean. Now, there are also issues related to ocean like pollution and wind farms are coming up, and we will also be discussing about disasters. The coastal disasters really it's become repeated very often. We are seeing that, and there are reports like marine heat wave, which is really making these things to happen very often now. So before monsoon, we normally don't have in Bay of Bengal and Arabian Sea. Now it has become common. We have in 2021, 2020, as well as this year, both in Bay of Bengal and Arabian Sea, we faced cyclone. This is simplest picture. I thought how the Earth's surface can be divided land versus the area of different countries. If you look at the ocean surfaces, a majority of the coverage is ocean. Now, the famous oceanographer Gibran said that one drop of water is found in all secrets of the ocean. That is to talk about that water has got salinity, which is common, or the proportionate of various ions and the ingredients of the water is same everywhere. Now, how does the ocean influences? We try to say that 40% of all the seabirds are affected in case of climate change, and how much of it is in the earth land surface is getting into that. These are all big challenges we face. Even recently, I gave a talk and a discussion on pollution related to plastics. So these are all various challenges in the global level. Various countries are discussing. Now, recently, the COP27 in Egypt countries have come together and they are committed in protecting. Important for you as a computational expert is on data sharing. The countries have agreed to work on data sharing. Now, we will also be talking about exclusive economic zone outside the EEZ. The United Nations, all the countries have agreed that there will be more protection, more aspects for the future generation to come over there. This is to show you the picture. Even though we have got boundaries by political boundary, the fishes do travel from one place to another place. Now, fishery is a big sector, protein as well as the economic part of it. However, again, there are data sets need to be analyzed. The importance of how various data related to catch and availability, the expectation from the computation is very much required. So I used to organize international workshops. This is one thing on islands where like we are living in a much better place in India. There are island nations where they are deprived of many of the aspects, but they face the vagaries of the ocean and the atmosphere like cyclones and many things are very common for them. We address the issue really in this regard. Now, when you talk about the computational part of it, you should know that climate change part. Climate change is not left only the policymakers or the NGOs. It's the people like you because they play a major role. The experts like you who have analyzed a large amount of data sets to bring a prediction to that. So we'll briefly discuss maybe if you have a time glance through IPCC report how this computation has really helped us to understand about the climate change, how the effect will be in future. Because this is what is very important for us. Unless you show computational result to the policymakers, they won't be able to accepting that. So ocean covers again 2/3 and contributes to the global warming. And here, how the climate change is affecting on the imparting of the ocean is very known, including the sea level rise and also depletion of various ocean resources. And again, we are talking about how this can be controlled. So here we'll talk about sea level rise. Sea level rise play a major role. The recent IPCC report 2 years ago, it was released said that 10 cities in India, they are going to be affected by sea level rise. And again, there are discussion like how they got the data to analyze close to the shore. The important here is when the sea level rise is affecting the cities, the impact from the population is very high in our region because majority of the people are living along the coast in the most populous countries like our country, Bangladesh, as well as China. So again, this plays a major role on how these results could be analyzed, how the newer thinking are required in this regard. Now again, you are also involved in this aspect on the sustainable part. You know very well that 17 goals have been identified by the UN agencies. And again, the SDG 14 talks about the life below water. If you are submitting any projects, try to link to SDG. There are funds available, including on climate change. There are funds available. You can start thinking and working on such aspects too. Now, when you talk about sustainable development, health, economy, education, energy, and for us, environment really is important for us. When you talk about environment, we talk about clean and healthy ocean and blue economy, renewable energy, and sustainable environment. Here, the ocean provides, as I said earlier, also the transportation part is very important. Majority of the oil transportation is coming through the ocean, and also medicinal, many plants are giving that. When you talk about marine ecosystem, it's very complex, even though it's a role of a biologist or a chemist to discuss about that. But again, the role of you will be very much required in interpreting this data, creating codes and tools and helping these oceanographers or marine biologists to think about that because it's very complex. Still, it is not fully understood. Now only there are thinking about collective approach of all discipline coming over there. Now, resources, yes, there are ocean resources. We are working on it, living and non-living resources. How to exploit these resources? Again, IoT-based system or robotic systems are very much required in future, so that in a sustainable manner, these resources can be exploited or used for the human application purpose. This is the government of India's launched blue economy policy, and also a deep ocean mission is a big program which Honorable Prime Minister has launched it. So these are all aspects where there could be a role, there will be more amount of data sets, there will be more amount of expertise and required by all of you to work in this discipline future to come. And ocean process, when you talk about that, it is really complex. The conditions like temperature, salinity, waves and tides and currents. At present, the models do run. They give a prediction much better, but however, they have their own limitation. Most of the model don't use waves because that is getting them more complex. Now, energy resources like gravitation, solar radiation, and winds, these also need to be taken into account when you run the model and work on it. I will share with you how complex it is having this variable of both ocean and atmosphere together for the prediction of the cyclone or any other coastal hazards. Having said that, we'll stop here related to ocean. When and where we require, I will briefly tell about related to this aspect. We will get into how the policies are being evolved, how the United Nations play a major role in regulating or controlling or having a role by which the countries come together in protecting the environment where we live in. And also like a sustainable development, we need to leave for the future, not to be exploited by this generation. So that is what this ocean policy is all about. Now, the UN has established with a real purpose of peace and security and adoption measure to strengthen the universal peace and cooperation in solving the international economic, social, cultural, humanitarian problems. Related to that, there is only one accepted convention. We call it UNCLOS, United Nations Convention on Law Oversea. This is only one which is accepted by all the member states. Whatever we have it offshoot of these aspects which has come into the picture. And it took about 12 years for them to evolve. And this is a very important course I teach in IIT Madras. It is a quite 10 hours lecture. I had an opportunity to visit and attend various UN meetings. This is in New York, and I had participated in Geneva. Even last year, I was invited, and UNESCO, I was in Paris, many meetings I attended, including UNEP in Nairobi, and many more places. So these are all my rare experience I thought I'll share with you. So when you talk about the law of sea, there is a separate body in the United Nations which is under last. They deal about that, and they also brought in all the UN bodies together. International Maritime Organization is linked to the shipping because they regulate the ship related pollution. Now again, you have a role to play. Autonomous ship is coming over there, where in future there already one ship, Mayfair is one ship which is sailing. There are no crew, nobody is there. It is being controlled from outside. And there are also IoT based sensors which has been evolved into the ship, and that can really monitor and really there is a lot of requirement for experts like you to work in this. So IMO is really working in that aspect. They are bringing out policy which could be used. Again, pollution from the ship by usage of fuel, that need to be regulated. World Meteorology Organization, as I said earlier, is an important body, specialized body in United Nations for operation of meteorology, hydrology. Now they have started working on a Earth system approach where all disciplines are together. They are thinking about it after 70 years of existence. That's the reason as a ocean component, I am representing many committees. I had a discussion with various experts in the meteorological field, and we had published one concept paper in last year in WMO newsletter also. And in the case of UNESCO, there is an Intergovernmental Oceanographic Commission, IOC, where India is represented by our ministry. And that is the one which is really providing the focus on marine science and most of like as research component, and the research component leading to policy. Last week, the IOC assembly was there once in 2 years, all the member states or countries, they come together. I was given an opportunity to log in from Chennai, and I was really attending these important policy decisions, what they have taken in protecting the environment and sharing the data sets. Now, One more organization important for you to know is UNEP, that is the Environment Program, that headquarters are located in Nairobi in Kenya, and they do work on ocean related aspect. And all of them concentrate on small island developing states and island nations and also least developed country. Now, this is the one clause which is really we call Constitution of the Ocean. It comprises about 17 chapters and 352 articles, and that deals with various components of the ocean, how the ocean can be monitored and controlled. Herein, they have brought in legal boundaries. I thought you should know about that. You would have heard a name called EEZ, Exclusive Economic Zone. This particular picture defined the ocean marine affairs in the six component, like internal waters, territorial sea, contiguous zone, exclusive economic zone, and continental shelf and high seas. High seas is the open ocean where anybody can do any activity, including a pipeline or flying of aircraft. You can see that within the national aerospace, other aircraft cannot fly. And we always use a terminology called nautical mile. 12 nautical mile is 1 nautical mile is 1.8 kilometer. This is up to 12 nautical mile is territorial sea. Another 12 nautical mile is contiguous zone. Up to 200 nautical mile is exclusive economic zone. So this picture will show you the exclusive economic zone is the sovereign rights of the country. Like you have a land, you have a rights in the ocean too. And globally, there are more than 190 countries, and they all have got their own EEZ. You can clearly see that 50% of the ocean surveys is covered by EEZ. Why I'm showing is that as an oceanographer, we need to collect data. When you want to collect the data, only the respective country can collect the data within the EEZ. Other countries cannot do without their permission. So when you talk about climate change, running your model, working on it, you need to get data sets from these exclusive economic zone of the respective country, and they should be able to share with you so that you can fine tune the model. That's the reason at times you will find that the prediction is not correct or sometimes it's not working, mainly because one is the data sets are sparse, it is not fully covered in the ocean. In addition to that, within the EEZ or the exclusive economic zone of the country, like in India, we are much better. Like I can say handful of countries, India, UK, USA, Japan, Canada, up to some extent China. And these are all the few countries, Germany, we are much better off in collecting data sets and sharing. Not many other countries having this expertise and the resources to go and work in the sea. Now, as I told you earlier, the WMO reforms and which is really playing a major role, and they are also supporting smaller countries to collect data sets. Why I'm showing all this here is that the days to come when the countries are started sharing data, you will be having free access to any other data sets to run your model to anywhere in the world. That will really help you to go for a newer thinking, newer ideology, not only for our country, you can also work with other country data sets. This is on work which I told you earlier on the computing aspect, how the supercomputer need to be evolved. And we had a long discussion with HP and many other manufacturers to work. And definitely the days to come, this computing facility will improve on the prediction level. So important part in the ocean component which UNESCO IOC says that and we cannot manage the ocean if you don't do the measurement. So measurement of the ocean is very important, and we need to improve our scientific knowledge on ocean climate and ecosystem, and also the human vulnerability. That is very important. How do you give the forecast? Current forecast is only a few days before. Can you give much earlier so that the policymakers or the local district collectors, the administrator can evacuate the people? So this knowledge need to be improved where only the computation facility can help. Now, what are the parameters that can be collected in the ocean? This has been standardized now. We have got essential ocean variable. This is derived from the essential climate variable. ECVs are the one which was first evolved for climate studies. Now UOVs are the one which are used in the physical, chemical, biological. These variables we collect data. They come in a different format. There are various sensors to collect these data sets. When you're running a model and you're working on it, you should know that what type of UOV and what is the resolution of that, and because that will really help you to run the model and have a better prediction in using that. So we also IOC and INCOIS in India, they conduct a training program. I thought that will be useful for you. They call Ocean Teacher. Please log in. There are online training programs out there. Maybe you can follow me in LinkedIn and Twitter handle. I always provide a link whenever such training programs are freely available. It's always, if you have a urge to learn or interest to work on such a discipline, these training programs are really helpful, and you get connected to people who are ready to work. And we also work on a gender balance, bringing out newer generation or younger generation replacing that. That's what we are focusing now, how the young students can be attracted to work in this discipline. Recently also I went to school and motivated them to work on this discipline, because we need students to work and come with a newer idea to work in this discipline. So the UNESCO has divided into 13 parts in the ocean and to collect the data and share. India was chairing for 2 years, and I was nominated. I was a head of chairman of this 13 region, coordinating these 13 different region, about more than 100 countries, and I was able to bring out some policies and training program in during my tenure. So that was a good experience for me to work in different disciplines and get accepted by these people. Currently also with the UNESCO in Boost program, I'm linking to 150 countries trying to work out a meeting, online meeting, first time in October, and with the European Union in September to work on different aspects of ocean data collection and modeling. This is one important thing you should know, that United Nations in General Assembly, all the countries have come together and they have declared that UN Decade of Ocean Science for Sustainable Development is 2021 to 2030, where the science we need for the ocean we want as a slogan, where there are various projects are there. Even you can submit, you can go through that. At times they give a call. You can have your own activity linked to Ocean Decade, and that will be really helpful for you to get connected to people and start working in this direction. Now, when you talk about ocean observation, that is nothing but data collection on the ocean and weather and climate service. Before that, we should know what are the differences and similarity between the ocean and atmosphere. Air and water have extremely different properties, and they can be compared. About 10 meters of ocean is equal to the weight of the entire atmosphere. That is important part to know. Heat capacity of top 2.5 meters of the ocean is equivalent to that of entire atmosphere. And additionally, top 2.5 meter ocean contains the same amount of water as the entire atmosphere above that. So these two parts very important, because we work on air-sea interaction, because both are fluid. Air is also fluid and water is also fluid. And when you run a model, work on it, you should know this aspect on the dynamics part of it. While both an atmosphere are governed by the same equations of motions are same. Uh, However, the circulation characteristics ocean has got, in addition to that, ocean circulation, upwelling phenomena, this is making it more complex to that. So first order, second order a differential equation, when you start using it, it becomes more and more complex in the case of ocean. Of course, yes, atmosphere also it gets complex as we proceed. But the RC interaction is much more complex to deal with that. In the case of WMO, what they do is they ocean and atmospheric prediction. Here is an important point in India. When you have a cyclone, we also give a warning to the sea level rise. That is very important. How much amount of water increase can take place. So this is only available in India. Many other countries they don't do that. So we have both ocean and atmospheric in the same ministry. That is possible. And important point is time scales. What time scale we are talking about ocean and atmosphere? It's running into sometime minutes to hours to. In the case of long waves, it is coming to the days and weeks. And so this is very important for it. How the seasonal climate prediction. Climate is long term. When we talk about long-term prediction, how the ocean and atmosphere can be useful. Here in the deep ocean is still not understood. That is a storage of information related to climate. It's available there. We do have data sets, but again, somebody has to think differently to understand about that. So weather forecasting, I will show you one small case study where we have published papers in the forecast. We run a ANML model, and now that was useful for the current prediction purpose. Now cyclones. Many of you are faced, you would have noticed it, being living in a coastal region like Vizag. We all have got the same problem. The issue there is the Bay of Bengal has got more cyclones compared to Arabian Sea, ratio of 4:1. But the cyclone frequency has increased now in the recent past. However, the effect of cyclone, the number of people who have died is much less compared to what has happened earlier. It has gone to multiple single-digit figure. Mainly because we have improved our observation, data collection, we improved our model, we have brought in awareness among the people and information technology. India Meteorology Department is supporting the whole region. Recently, we are honored, and the Vice Chairman of WMO is the Director General of IMD. He has been elected. That's mainly because our forecast is not only for India, for nearby countries like Bangladesh, Myanmar. Up to some extent, they share the data with the UAE and Middle East countries. And this is the pre-monsoon. Monsoon is a period you know very well where the rain comes for us. And prior to the monsoon, how many cyclones are there? And post to the monsoon, how many cyclones are there? This is up to 2017. Now the frequency has improved, increased now, and mainly because don't bother about much on atmospheric aspect, but when you are running a model, when you want to work on the ocean data, you should know about what are all the different the physical phenomena which is happening and the complexity of what we are facing. In the case of what you can see in the picture is Bay of Bengal is more complex compared to Arabian Sea, mainly because of fresh water which is coming from Ganges and Brahmaputra river. This fresh water is reducing the salinity of ocean in the Bay of Bengal, and that is what we call stratification. The stratification, I think, but layer by layer of ocean is different compared to Arabian Sea, which is uniform salinity. This affects the amount of heat that can be stored, and so the heat capacity variation is taking place. That is what is affecting us in and identifying the monsoon and the cyclone track. For the cyclone track is always followed by surface sea temperature, and we provide the data and we work on it during the cyclone time also. And these are all the events to talk about that. El Nino is, well, currently we are doing in the El Nino period, which is a long term. All other aspects, like some of the biological process are millimeter and decimeter level of spatial scale, or in the case of time scale, it is seconds and minute level. Whereas in the weather and atmosphere conditions is much larger, and you got to talk about regional process, which is much more complex involved. Now next comes to run your model, you need data. To run the data, what are the sources for you? That's what I thought I will discuss here. How the data sets are collected, what are the instruments being used for collection. One is satellite, another one is in situ measurement by instruments, another one is by shipboard measurements. This is by satellite. They have got polar orbiting satellite or UOs, and they all provide data continuously from the ocean. And we get surface sea level height and SST, and that is being compared, and various data products are available. If you are interested, you can always see the data product in MOSDAQ website of SAC as well as the IMD website. And satellite derived wind measurements are there. This is a simple product for you to show that how the results could be brought in. Let's just to get a glimpses of that. These are all some instrument. These two ships belong to our country. Sagar Nidhi belongs to NAOT and Sagar Kanya belongs to NCPR in Goa. And this is the current level of different type of instruments, and point shows about instruments which are floating at sea and collecting and sharing data sets. Coming back to India, we have two different water bodies called Bay of Bengal and Arabian Sea. And the Bay of Bengal is largest bay in the world, and we had Indo-US collaboration to work on it. And also when you talk about oil pollution, is much more, chances are much higher here because 60% of the ship traffic is in our region. Again, when you talk about Arabian Sea, it has got a very large area and less amount of river and discharge into that, and less prone to get cyclone over there. It is again a picture of how the data collection is taking place from the different observation. These are all different tools. I'm not explaining you much. They'll be talking about that. Monsoon is very important for us, mainly because the monsoon is linked to the economy of this country. A shift in the monsoon can affect the paddy or sowing, and the farmers get affected. So the current this year also small slow down of the monsoon, mainly because prior to that there was a cyclone which has taken away all the moist condition in the atmosphere. So monsoon is very important. Again, the monsoon prediction is run only by models, by computing tools, which is really advanced now. Our interpretation has improved a lot. We do collect data from the ocean waves, and India is the one country in the open ocean we collect. This is to show you how complexity to collect data. We have about 8 years, 9 years continuous wave measurement in the open ocean. And also we collect this such moved buoy data for satellite data validation, because any satellite will give a number that has to be validated. We call sea truth or land truth data, where at the same time the same satellite paths need to be validated. This we have done it. We are supporting ISRO by having such a conditions. Now, having seen that, Dr. Jaya, can we have a break now? 3 o'clock? Or should we continue? Dr. Jaya? Can we continue? Anybody can answer to me?
Yes, sir. Continue.
Okay, I thought we'll have a break and we'll continue. We'll have a break later. Okay. Now, many of you may be interested to know by now where will I get the data and what are the sources, whether it is freely available. Yes, I will share with you the data sets on the ocean component is available in INCOIS, Indian National Information Ocean Information Services in Hyderabad, where you can always submit your form. And for students, it is free of cost. And including in IMD, you will also get data sets. Globally, also there are sources where you can get the data sets and real-time data sets. This is the advantage of real-time. During the Amphan cyclone is the one which crossed during the COVID. We were all locked down at home on 12th May 2020. We started collecting data. We were running our data center 24/7. And these are all the locations. We have our own buoy systems deployed over there. NAOT is maintaining that. Now on 20th May it landed. So our prediction from the ocean really helped. When you run a model, there are 6 parameters are required for cyclone. Out of that, 3 come from the ocean, 3 from the atmospheric conditions. This is to show you how important is that to collect data. Now, this type of instruments is helping during the cyclone time. Now, before getting into that, I thought I will give you a brief about ocean model. How does the model work? How the models are used? So when you talk about ocean depth, it's approximately 4 kilometers, and you can see that the troposphere height is about 10 kilometers. And when you talk about ocean model, the sunlight plays a major role. And the heat balance is one thing which is briefly you should know. The oceanographers and meteorologists they talk about heat balance, how much amount of heat is coming out and how much amount of heat is being liberated. This work I've also done during my Fulbright study by having the measurements at sea. So the atmosphere is really playing a major role. And that is what, and what is the ocean component related to that? Earth surface is about 29% and 71% is ocean. And the ocean model comprises of physics and mathematics. And the changes in ocean parameters do affect the net radiation and the rotations and the wind and other forces. I told you earlier, the wave component is not taken into account because that will make it more complex. But the radiation processes has been well defined. Clearly, we know how much amount of radiation is there. So we have done very accurate measurement during the cyclone process, and that we have published work on it. Now, another component we should know about is the circulation. Circulation is a movement of the water, and the thermal structure, what has happened over 100 years. Again, the model simulation is helping you to talk about that. There are also underwater models to talk about underwater process, and about more than 10 models are there to predict in a different way. They've got their own complexity. When the cyclone comes, you would have seen cyclone has got surface phenomena. There is a more amount of air rotation you would have seen. Similar like that, underwater too. Underwater too, there are circulation and upwelling to take place. That can be properly brought in here. This is some of the measurements we have published paper also, and how far and how long the upwelling phenomena is affecting. The temperature and salinity data we collect up to 500-meter depth. That has really helped us to provide the complete insight into that. These findings are new, and we have published such work to understand about underwater phenomena. Ecosystem is nothing but we spoke about physical process in the case of cyclone. Ecosystem talk about biological and chemical too, along with that. The impact of all the three together, particularly in the coastal environmental conditions, we have one of the best in the world, having all the ecosystem like mangrove ecosystems, seagrass ecosystems, and coral reef ecosystems, and anything you name it, you have it here. But these ecosystems are very sensitive. Again, we are developing models to run and try to see how best any variation or any pollution what is happening can be properly monitor over there, because the marine organisms living in these ecosystems are also sensitive. One need to look into that aspect also. ROMS is one model which has been well defined and many of the oceanographers use, and that is giving you the clarity about how much best it can be there. Ocean circulation, this is one picture to talk about RFI and where how the circulation is changed. Now, when you talk about forecasting, what is forecasting? Forecasting is nothing but it is in the case of ocean purpose, it's an oceanographic phenomenon. That's all depending on the physical equation based numerical model in the ocean. Similar like that in atmospheric condition also. So it's a process embedded the time series observation itself. So we need time series data. That's the reason we need instruments like this, which can be deployed and monitor over there. The satellite imagery gives the remote sensing data. The problem is the importance of satellite imageries are they are all spatial coverage that gives a larger picture. However, the micro radiation is only up to 75 centimeter, less than a meter. So in the close to the shore, it's not possible for us to get what is happening underneath. So herein, what we have done in this particular work with Anna University, we have used the buoy data what you have seen earlier, and also the convention model we have run it, and we have done the prediction here. This paper we have published, how the tropical cyclone intensity prediction based on the hybrid learning technique. That's what we have used. This is to evaluate the combined models to predict the cyclones and intensity and track cyclone position. Because currently the past data sets that the history is not used for prediction purpose. Only real-time data is used for prediction purpose. If you had a past history, there only the role of AI and ML will be really helpful for us. That history will be really helping us. In fact, 20 years later, the same day, same time in US, after Katrina cyclone, another cyclone came. Maybe we joke at it that nature has a remembrance. But here in AI and ML can really helpful for a best results in case of an error assessment over there. The current techniques of weather forecasting agencies all over the world uses only numerical simulation model, and they do not take into consideration data about the previous instance of anomalous occurrences. So previous incidences, what has happened and how that is there, that is not taken into account, because anomalous occurrences will not be the same frequency in all places, and not all the coastal regions have the same slope of the seabed. That is, slope of the seabed, what they mean is topography. That differs. That's the reason they didn't use it. Here in this simulation, what we have done, we have simulated the scenario causing the disturbance, and using the real-time data and the normal machine learning problem-solving approaches, which form only hypotheses in their process, whereas we have used ensemble learning algorithm, where a set of hypotheses and their combination is used for such classification purpose. There are few publications we can go through that. The attempts are being made, whereas we are dealing with a large volume of heterogeneous data, multidimensional and dynamic sensor. That is what is we are dealing with that. In addition to that, we also need to forewarn the ship or the people who are living over there. The ship is moving. How do you understand what type of ship is coming, where it is moving, how the traffic safety and maritime security? That also we have taken into account when you run the model. We have used the deep learning technique for the data mining aspect, and the various architecture we have tried in this work, like LSTM and GRU-RNN and vanilla CNN and RNN. All this aspect we have studied and we have forced it, and we found which is really good in that. We have also used a real-time mode buoy data, like I told you, and these buoy data sets from oceanographic and meteorological parameters, they transmit data in real-time mode once in 3 hours. That is 8 times transmission to take place. Like you have 3 hours, 6 hours, 9 hours, 12 hours. So these type of continuous data, once in 3 hours data sets are used. And RNN is basically a neural network which is having the natural linear connection with a loop or a cycle. That is really helpful, but it has got its own limitation when you talk about the vanishing gradient and many aspects like exploding gradient problems. So when you run such a complex data sets and convince the meteorologists, we need to be careful. They may not even accept what we are talking over there. So we have to accept the limitations on that. That is what this professor from Anna University they have done. They've also tried the long short-term memory part of it, and we get a recurrent unit. And here the challenge for us is the oceanographic data sets have been brought in with a pattern simulation. With this constraint only we have tried and we have attempted, and this is the classification we have done. In addition to that, we have also tried with the bathymetry. Bathymetry is nothing but seabed, wherein the construction of the inundation water. Inundation is nothing but how much amount of water can come in the case of cyclone comes through that. So the bathymetry data is a part of a geological activity. Currently, globally, there is a project called Seabed 2030. Global bathymetry is being documented because after the, very well, the Malaysian aircraft 4 years ago, it was plunged into the ocean with more than 200 people have died. That time they realized that seabed need to be mapped. When they started mapping, they found a lot of anomalies. You all will be surprised. Similar like the Himalayas, there are underwater hills, and there's similar like Everest, there are underwater hills, and there are volcanoes do exist over there. So that need to be mapped and that resources to be there. So that is what CBID 30 to 2030, which is a Nippon Foundation is also supporting. So in these data sets are very important, including for tsunami as well as the indentation part of it, and the coastal boundaries are required. In the case of tsunami, what is normally done is that the tsunami waves, you know very well, the conventional wind-driven waves are the wave what we see in the beach, and there are tidal variation which is very less. The tsunami waves are long waves. After 2004 only we came to know a word called tsunami. The long waves are running into many kilometers, even hundreds of 100 kilometers. But the tsunami waves, when they travel, their pressure can be felt on the seabed up to 4 kilometer depth. Whereas the waves which are formed by wind-driven wave, that is only up to surface. That pressure won't be felt on the seabed. So there's a difference between these two. So what we normally we do is that we keep the sensor, that is a pressure sensor, which is in can give 1 mm in 6,000 meter accuracy. These are all very highly sensitive. Only one company is making globally, and that can give you in case tsunami wave is traveling. Now we know very well that tsunami wave is traveling. It is coming to the shore. Herein, what they do is that they use a different simulation technique, tsunami scenario technique like UTM grid zone or commit software by MIT, Massachusetts of Technology, standby indentation model by Tsunami N2.3. These are all some tools which predefine the scenarios they create and they try to give a forewarning. But the tsunami buoy system which we are deployed in the ocean can give and tell you really tsunami wave is coming. So for such prediction purpose also we can use ANML technique. From this work, what we have done, the weather data is volumetric and large. So much data sets are available, and we found that the LSTM RM technique used because it overcomes a vanishing gradient problem which is faced by RNN, and also we have also a little bit modified this hybrid heterogeneous work is really useful for us in concluding this. So another paper we wrote about the tropical cyclone intensity prediction based on the hybrid model. And herein again we discuss about various aspects and the dynamic parameters like heat content, atmospheric process, they are not taken into account. That's the reason such techniques still fully not accepted by the oceanographers or meteorologists, because we have not taken this aspect. It is really more complex to that. However, we have forced this model for the Amphan cyclone. That has really given a good correlation and the prediction was much better. Another paper we published on tropical cyclone prediction based on multimodal fusion across in India. in the coastal region. So these are all some work we have initiated, and this link I'm giving, these are open source paper. In case if you have a difficulty to download, read this paper, kindly send a mail to me. I will share all this paper so that you can continue this work, whatever we have initiated and left it. And this is one activity under the full pay program we have done, brought an importance on how real-time motion data collection is useful with experts from US and India. We are jointly presented, and that is well appreciated in the US. Now, we have also discussed about how the ocean acoustic data can be used. What we do, we deploy hydrophones at sea. We also deployed in Arctic, and after 1 year, we remove the hydrophone and download the data and analyze it. In the case of Arctic, we have published a paper in Nature, how the sound of rain and cyclone when it passes through that, and how that can be useful for prediction purpose. So the first ever paper on using acoustic principle in Arctic, that's the reason Nature has published that work. Here in the case of ocean animal, there are various animals which they produce different noise. I'm trying to. So this is to say how the humpback whale is creating a noise. I hope it is audible to you. I sent you a PDF file that may not be audible. So this type of noise we analyze. Again, we need a special technique. We use here deep learning technique. In addition to that, we also work on how the ship is moving, because this is also one paper was published in one of the American journal, using this ship sound, how the economy has changed, particularly how the ship noise is less in the case of COVID time, now how it is revised back. So it's very interesting work. Very few people are working in India. Our institute and NPOL, Naval Physical Oceanographic Lab, is working, but globally there are researchers where they are working. You can see it's all very low frequency noise, less than 1 kilohertz, which is being used. Now in Arctic, when we deployed, we can see that how walrus is making noise over there. There are many more such things available. Maybe if you have time, you can see that. I can. So they produce a different sounds, and the repetition knocking pattern. You can see that this is different. So we have got a signature of different animals and different noise and shrimp breaking noise. And with this, we will be able to identify for strategic application in case any other ship is coming over there. And this particular work, Economist has published it. My interview is there in this, how the famines and trade and science and improving, how like ocean prediction and modeling has really helped. This again available online. Maybe somebody wants to read about that. This particular author who has come from Dominic he had come from Hong Kong. He's a regional the economics reporter. He came down to Chennai, interviewed me. It's a very interesting piece of information, starting from history to current level of science and technology, how that is useful to farmers and also the fishermen in this region. Now, I will also sharing with you on where all the data sets are available. This particular work, I was invited by the US government in a program called Tech Camp. They conducted first time in Cochin. They have selected 55 different people from different walks of life, like teachers, reporters, students, government officials. And there are 8 experts were selected, including me, and we all have to make them to come and attend their session. It is not like they divide them into group. Whoever is giving good lecture and they will come and sit. If they don't like it, they can walk away. In the end, they submit proposal. We being a mentor, we work and supported them. So there are some successful candidates, and the funding is provided by US government. Wherein my topic was on ocean data. I've collected a lot of information about ocean, and even I was surprised where such free data sets are available. These links are available there. First is INCOIS, where I told you earlier, our sister institute in Hyderabad, and you can go through their website and request for data sets what you want. Then ISRO and SAC MOSDAQ site has got satellite data which is available, and our another institute called IITM Pune, where the atmospheric data sets for long-term observation. That is, even data archival is there. You can always ask for it. And HMRWF will provide a modeling data. Model output data sets are there. Even if you want for your work, you can use that. And in USA, NCA, they provide, even some of us, we use that data. That is really helpful. I have given the complete list of different data sets what is available there, including acoustic data. Even if you want to do more, they are available. But it's a process data. And National Data Boy Corporation in USA, they were established much before India, and they also provide data sets free from more than 100 stations. That also you can Google search and see what type of data they are collecting, what is being shared over there. Next is OSMC, which is Observing System Monitoring Center, and they also is part of GOOSE in UNESCO IOC. They also are responsible. Ocean Sites, I was the executive committee member of Ocean Sites, where we have various stations in the ocean we call reference sites. We share the data to provide quality of data what is provided. So this is a metadata. Metadata is nothing but information about data handling system like a ocean platform. What is the frequency? What is the sensor available? What is the make? All those things metadata sets are there. So these metadata sets can be obtained from OceanOps, that is in France. Google search, you get it. Copernicus one area where they provide free data sets for Europe. And PODAC is another area where you get again in data. So these are all list of server where you get free data sets. And Asia Pacific Data Research Center also provides data. And Argo Floats is the one profiling floats, which is one of the successful program more than close to 20 years now. And again, they provide data products. Even they got tools which can be used by students. And acronyms what is being used I have listed here. And we too had Indo-US collaboration. These are all the mood boy which I was handling, about 18 of them, and 6 more tsunami boys. And under the Indo-US collaboration, the government of India and the government of the USA, they have agreed to share the data outside the EEZ on free of cost. There are 25 moorings by the Arama and about 9 moorings by us. This 25 plus 9, 33 mooring, any data, anything you want, that is being made available. These are picture by Scripps Institute of Oceanography in USA, who had funded this program. They have done a video, and the ship came to Chennai, and we had a training program from India and US students, and they sailed together. They use advanced tools and collected data, and that is really very interesting information about Bay of Bengal, and the special issue of Oceanographic Journal was published. And I too published a book by Springer Journal. I'm glad to say that more than 18,000 downloads of chapter and more than 150 books have been sold. I happened to visit the University of Rhode Island, where on the bookshelf of the library I could see my book. This is a highest satisfaction like us. We are very happy that whatever work we have done, if it reaches students, that was picked up by somebody out of 30,000 books, and somebody showed it to me. Thanks to that, and that is really so. With that, I conclude the first part of it. Next, we'll go about IoT and robotics part. With this, we'll have a break now. Maybe after 5-10 minutes, we'll join again. Thank you very much. Before I break, do you like to ask questions now, or we will have it later? We'll come back after 5 minutes. Is that okay?
Okay, sir.
Thank you. Can we start now?
Yes, sir.
So part of this talk, we'll get into the last part of that, that is autonomous systems underwater robotics. So The types of underwater robotics which are used, we divide into two parts. One is a remotely operated vehicle, which is nothing but there's a cable connected to the ship, and they keep.
Excuse me, sir.
I'm audible.
Your PPT is not
Not
visible, sir.
projected. Okay.
Yes,
Wait.
sir.
I will. I'll do it.
Yes, sir.
Wait.
Yes, sir.
Now, are you able to see that? Okay.
Yes, sir.
Yeah, correct. That is one. Sorry. Is it correct? This is the. Are you able to see that?
Yes, sir.
This is the one I am showing now. Okay, fine. So these are all two part we can divide underwater submersible. I want to differentiate between submarine and submersible. Submarine is used by Navy, where large number of people can go and do, and they have a limited depth. Whereas submersibles go deep ocean, and you can see up to Mariana Trench also. People have gone, and 11,000 meter. Most of the submersibles are about 6,000 meter depth. So ROV is nothing but remotely operable vehicle, which is we can control from the ship. We lower with a cable, which is electromechanical cable. Now, robots are displacing the professional divers. Divers are the people who carry the shallow water. They have scuba diving, and deep water they call diving bell. They used to go and repair underwater any breakage of pipeline, welding, and all sorts of things. Currently, they are being replaced. There are no human direct involvement. These are all controlled by robotics. Now there are 6 emerging trends, we call it. That is nothing but how, in the case of ships, they can be used for hull cleaning robot, or the pollution cleaning robot, or human-inspired marine robots, or underwater robotic grippers, and also the biomimetic underwater vehicle. I have also worked on biomimic, where we try to duplicate, and RoboFish was developed by me with my student. And these are all interesting area we are trying to learn from the nature and trying to create our own robotics. This is an autonomous navigation using AI and automation. This is really coming up. You can Google search and read. These are all topics I'm giving. IBM has developed this particular ship, and this is a research vessel called Mayflower. And I'm also in touch with some experts working in IBM. And this has not come to India. If I succeed, I'll be able to bring this autonomous vehicle, which is completely controlled from the lab, and it is crossed. It is doing circumnavigation, and really AI and ML, AI and automation is really used in this aspect on navigation, and going through the bad weather conditions and collecting data. They also interface a lot of IoT tools like ship's roll, pitch, ship movement is interfaced to that. In addition to that, atmospheric measurements are interfaced to that. A complete set of automation has been tried out. This is futuristic. Maybe 50 years down the line, most of the ship would be replaced with such autonomous vehicle, where IoT and AI is really playing a major role. This is that IBM engineered crewless ship, we call it. And they have used a 3-layer technology like sensory inputs, real-time machine learning, and analytics, and decision engine. The decision engine part is very important. And of course, initially they had an human interference. Now the decision engine takes a decision on the basis of the real-time data. For example, sea is rough, and the speed need to be modified, and that would take care, and the decision making process, like a human decision making process, normally that is done by captain. Here it is done by the machine itself. And IBM experts use the peta types of data to train the machine learning models, and they wrote rules based on decision making for the decision engine. That's what they want to try all over the world, because some conditions, the environmental condition will vary from place to place, and they need the models should react autonomously to take decision. So this is really futuristic. This data is slightly low, but it is crossed a longer distance than what is projected over there. We have developed autonomous ocean monitoring system, which is used for science and prediction and analysis. You can see the ship, and it is doing 3D bathymetry. Like seabed, like what we are seeing in the like aircraft when you're flying, similar like that, you can do 3D bathymetry. So there is SWAT sensors that fitted on the ship hull. Left side, you can see a yellow color moved buoy, which I was involved, and we have developed indigenously. Now Indian-made systems are working, and they transmit the data through satellite. There are also autonomous systems which will go down and come up autonomously, and they transmit data. So when you talk about autonomous system or data collection, it could be satellite or a subsurface or a in-situ surface based. We need to have a long-term data sets to collect for. We have seen about weather and climate. We call either Eulerian approach or Lagrangian approach. Eulerian approach is the system is fixed, ocean is moving. In the case of Lagrangian approach, the equipment also goes along with that, and it collects data as it goes. We call profiling floats. Each one has got its own purpose. Tsunami buoys for tsunami early warning, and automatic weather station on board the ship that has got its own intelligence, like ship movement is regularly taken into account. Wave buoys for wave measurement, HF radar for coastal current measurement, and we too have Indo-US collaboration shipboard measurements, and the drifter is only for surface drifting, and the yellow color middle one is moved buoy to collect. Argo floats is the one which will go down and collect, and it takes about 20 days to go down, and pops up to the surface and transmit data in real time. This is Argo float. You can program it. It works on a buoyancy variation principle. It's a completely underwater robot. And when the buoyancy variation of 50 grams, if it is heavier, it will go down. When it is pumped out, it becomes lighter, it pops up to the surface. Its power is consumed only for data transmission. For going down and up, it's only buoyancy variation. This is one of the revolutionary changes, which is really helping to get temperature and many other data up to 2000 meter water depth. So another instrument called glider, again autonomous system which will glide down. Again, it works on a variable buoyancy, but it don't go much deeper. It will glide down and collect data and see sawtooth principle. And we too have got in India, and we are developing indigenously. Data is the one which I worked on it. We have got various instruments, like sensor could be analog or digital. We have got meteorological sensors. We have got underwater oceanographic sensors. We do have for wave measurement sensor, and the data logger plays a major role, which all the data sets are stored and transmitted. And initially we imported data logger. Later on we developed it in India. We have also developed 6 variants out of that, and we have used Indian satellite for applications. We have also brought in a new technique, like you have a cyclone, you want to have a large amount of continuous data sets. How do you make it intelligent enough? So what we have done, it keeps monitoring the pressure. The pressure variation is low, it starts pumping data. If the wind speed is high, it starts pumping the data. And when the wind speed becomes normal, it comes back to normal. This is my idea, but it worked. It took some time for us, because in anything in ocean, when you deploy after 1 year only, we can retrieve. It's not possible to test immediately. But now currently most of the systems we have got our own patent. Nowhere in the world this technique is there. I was invited by NOAA, their hurricane task force, one of the highest body. They asked me about explain about this development what we have done in India. This is what recognition when you start developing such system. And a platform, this is nothing but a system, either ship or a moored buoy or a floating buoy system. So how do we interface that? And when the data sets are transmitted, it should be encrypted, I told you, and it should be in a proper format what we want. And the reception also is possible. We have a reception station. And we too developed another important thing on power source, where we got solar based as well as a lithium based. If the one is taken, sometimes fishermen take away the solar panel, it switches over to the lithium battery. Why we have done both is cost part of it is much easier. So this again indigenous development, we have done it in ourselves. So we have also developed a data acquisition module with IoT interface, where the various stages of development have been play prototype, lab model, field model, industrial product, industrial testing, then acceptance. Finally, industry is making it now. We need a specialized ship to go and deploy, and we need the ship should have a facility by which it is positioned in one particular location. We do have the bathymetry completely. We survey when we deploy the location. This is a simple picture. A minute show you how much time it takes for us to deploy a system. Only once in a year we do. In a year we go 4 times in different locations, about 200 days of sailing. Once we sail out, we don't come back after 35 days. But complete system is indigenized, and the depth will be 4 kilometers. So this is what at 4 kilometers we are deployed. It takes about 3 hours. This is what is a rope is being paid out. Finally, we drop the anchor. This is about 2 ton weight, and these are all floats which will help you to, when you release it back, it comes back to the surface. It's a definite technique. We have done it more than 300 times. I'm glad to say that India has got this expertise. Very few countries have got this. So we got a dedicated team, and the data comes to our reception station. Again, this model is developed by us. It's completely IOST and intelligent based system. And it is when we go back after 1 year, we go back to the same location, we give the release command, and system will release and pops up to the surface. Now we too have got robo boat we have made, where the boat has got a camera. You can see the pristine ocean, how the fishes are moving around early mornings. 7 o'clock we have taken this picture, and we too have a patent for this robo boat. And this is a satellite. The data sets are continuously once in 3 hours transmitted. It is being received, and the power consumption is there because it is a geostationary satellite. 35,000 kilometers to go back and come. So the important thing is during tsunamis, the data reception should be much faster. We have ensured that there is no data latency in that. This is a complete platform. More than about 18 such systems are there, and continuous data sets we had. We have large amount of inventory. I'm glad to say that I could revive this program. This program was completely stopped in 2008 to 10. To 2010, I came back from Sri Lanka from my UNAP position. I revived it. Till now, it is working satisfactorily. And these data sets are available within COIS. And you can see at the bottom, continuous data. Even in the land, you will not find such data sets. This is a bottom temperature up to 500-meter depth. I forgot to mention, we have temperature and conductivity data, also wave data. This shows how 500-meter temperature and salinity variation is there. And we too, I told you earlier that we help ISRO to have a validation purpose. These are bottom data sets are completely for sea truth validation. After 2004 only we came to know about tsunami, which happened in the Nicobar Islands. And we developed this instrument called Tsunami Boy, which has got 2 units measuring the surface pressure, I told you earlier, and underwater only acoustic transmission takes place. Above water is the radio wave. So we too have underwater communication using acoustic sensor. It comes to the buoy system. From there, it gets transmitted through satellite and it reaches shore. So the bottom depth is 4 kilometers. Satellite is about 35,000 kilometers. It all had to happen in 5 minutes time. We have succeeded. Other than the USA, India is the only agency, only country who have got this technique. More than 13 countries, they are all importing, but we have developed our own system. I was instrumental in installing. I was also chairman of this committee in the international level we call International Tsunami Trip Partnership, where we could proudly say that we have succeeded in developing it. And this is another interesting project which is called SMART. I am also in the joint task force of this global community. You know very well, today we are talking is mainly because of telecommunication, and telecommunication cables are laid on the seabed, like Chennai to Singapore or Bombay to Mediterranean Sea. These underwater telecommunication cables are laid. Right side bottom, I have shown you this telecommunication cable. They are all fiber optic cable. What we are discussing in this scientific community is that can we ask this telecommunication company to attach a sensor to that? There are about 10 lakh kilometer level of various cables. You can see that all over the world. So we have succeeded in one in Portugal. They'll be attaching sensor to that. That will be useful. 1 second data you will get. Currently, it's very difficult to transmit through satellite. So our prediction level, why I'm telling here with more length is, like you, computing experts are required. When 1 minute data sets will start pouring in, somebody should analyze and tell us what variation they have found. So this is what is a futuristic thing we are working. I'm part of this team. We meet online. And when I went to Geneva last time, I met them also. It's also 3 UN bodies are involved: International Telecommunication Union, WMO, and UNESCO, IOC. Now, when we talk about that Google Sundar Pichai announced 2 years ago that they got algorithm by which they are able to predict cyclone. Why I am showing is that you got a conventional way of predicting tsunami. Earthquake-based tsunami is possible, but 2018 when Indonesia had a tsunami, that is a like landslide, you had a sea slide. From that tsunami occurred. Indonesia had a land-based earthquake leading to tsunami. That is not predictable by the tsunami voice system. What I have done. So we wanted to organize an international meet when Sundar Pichai announced that they have predicted cyclone, they have predicted tsunami. That is mainly because they have got 16 cables owned by them, owning about $16 billion. These cables, they have developed an algorithm with an expert from professor from University of San Diego. He has given them because normally when the cable is laid, they monitor the health condition of the cable. It's very calm, quiet, underwater, no disturbance. But when they're on the surface of the sea, when some small disturbance like rain take place, the acoustic waves to travel on in the ocean. That variation they could capture. So this is a completely new thinking which is not thought, and we are trying to get that information from Google. They are not revealing that, but this is a futuristic way we are trying to meet by mathematicians, geologists, geophysicists, and including students to come forward and have a newer thinking. How do you improve our prediction? How do you understand? Because Earth is still not understood. We always say the man has landed in the moon, but still we are not understood the Earth, what we live in. So this is what is a challenge in a futuristic way. We need to work on it in a different level. I had an opportunity to install this Arctic Observatory. It's about 1,000 kilometers from the North Pole. I could go there and install this system. More than 30 lakh data points we have from 2014 to till date. Every year somebody, some expert, some technician go there and service and redeploy. But the first system which was deployed, designed and deployed by me, for that, the Honorable President that time, Geoscience Award was presented to me in Rashtrapati Bhavan. This is a really interesting experience for me to contribute in a very small nano level for such an activity, because this was even quoted by Norwegian foreign minister at that time, that how a country from tropical region can come and deploy a system which worked 1 year and continued now. Till now it is working. So these are all something which we are proud to say, and this was also part of a UPSC exam question on this abbreviation what we brought in, like a INDAR. Now, this is a reception station, again, one of its kind in the world. I don't think any other country has got where 24/7 manned complete data reception is possible, including the inventory of more than 2,000 sensors and their validation. We also have got calibration facility. When you talk about IoT, everything need to come all together. You got a best practice, and that has been accepted by UNESCO, IoT, and we have also published that work on how do we ensure that the quality of data what we provide is good. And these are all different cyclones we have captured. There are more than 40 different type of cyclones, and everyone has got different signature. And we have published large number of papers. Until my retirement, almost 10 to 15 papers we published from these data sets. Now, this is what Tsunami by indigenous development really reduced the cost much better. You can see that we have brought in much better level, including that we are going to replace with the Iridium satellite. The buoy cost is reduced by 75%. We have a big saving by having this development and IoT based principle. Now, when you talk about robotics again, remotely operable vehicles are like this tethered cable. We have got in an NIoT where we can lower it down, and the remotely operable vehicle can be maneuvered from the ship, and they collect data, sample, and photography and videography up to 5,000-meter depth. We have operated and we have brought back. We also got autonomous underwater vehicle, which is completely left unmanned. We can maneuver it from the ship. We have bought it from Kongsberg, a Norwegian company. We have tried up to 5,000-meter depth. So really a challenging job for that. We are developing a manned submersible, like 3 persons can dive down. That is at the bottom. It's called Samudriyan. Few years down the line that would come through. I have also seen manned submersible Alvin when I visited Seoul Oceanographic Institute. That has done more than 5,000 dives, and last more than 40 years they have been operating that manned submersible, which can get down there. So we need on board the ship such a huge facility to handle these heavy instruments, and the sea need to be calm, and we go far away from the shore. Most of the time our sailing is about 30-35 days, and we operate and complete the activity and come back. These are the interesting picture, underwater picture up to 1,000-meter, 2,000-meter depth. There are animals do live over there that has been captured by us, and we have also had a opportunity of installing the Indian flag over there. This is an AUV which is going there and surveyed. underwater bathymetry survey, which was maneuvered and collected the data. This is during the deployment, including another system was for Antarctic purpose, was developed by NAOT and deployed over there. So all these things call for underwater robotics techniques and the maneuvering part of it, and how the thrusters could be interfaced, and also IoT technique to interface various scientific sensors to that, and also acoustically transmit to the surface. And in addition to that, they need to have an intelligence to have a health monitoring aspect. In case of an emergency, there are also redundancy added to that. They can pop up to the surface. They won't be lost. They lose a ballast weight and come back to the surface. So these things come by experience, and also the maneuvering part, the stability is very important when it maneuvers over there, and the speed and monitoring aspects all are possible to be developed, and that expertise I got. And underwater visibility is very less. We need to have a special strobe lights and cameras to control over there. So the mission works like this, where we have the mission positioning, path planning and control, and the navigation system and the vehicle system and the stability of the vehicle and the sensors too, different type of sensors which is interface. This is what is a simple block diagram, but the whole activity of the robotics is really complex, including the position fixing over there. So this is a simple picture. You can Google search, and maybe you have a lot of videos, underwater videos. There are also underwater cables in Neptune. They provide real-time part of it. Please do see that. Then you get an enthusiasm how these two animals live there in deep ocean. It's the first ever manned submersible in the history, which happened in 1932. And this at 7,000 meters in Mariana Trench. The pictures which has been taken away, and yeah, there. And this is what is Indian design. We have brought in like Titanic shellware, and also the other aspect like air pressure tank and forward and thruster, all are housed over there. The major system can be divided: human cabin and buoyancy and control and navigation and power and propulsion and life support system. That is very important. Emergency support is important, and the mission payloads like manipulators, they are all important to that. So all these aspects are taken into account, and the buoyancy we use synthetic foam, and the ballast also fixed ballast and variable ballast. Fixed ballast is the one which is lost in case you want to emergency pop up to the surface, we use it, and also the trim control, which will help you to do the proper navigation. So the control, among all the things, the control system is very important. That is the one which normally people fail it, and that requires a specialized skill. We also collaborate with IIT Madras in developing this control system over there. The challenge in the deep ocean is pressure increases. You all must be aware that 5,000 meter at 500 bar pressure. I had posted in LinkedIn about this Titan submersible, which 5 people lost their lives, and how it got imploded. Maybe if you have time, people, please do LinkedIn my post. It has already crossed more than 20,000 impressions, wherein I've brought in here the importance of pressure, hydrostatic pressure, and where when the deep water is much higher and the temperature is very low and acoustic communication is possible, corrosive seawater and dynamic medium, absolute dark, completely dark over there, and also limitation in our understanding. The material selection and technology is very important, mostly titanium. In the case of manned submersible, titanium 6Al4 we is used, and that has got a best weight, and there is also ELA grade to that. And this is a personal sphere. This goes through various level of testing before it is being employed over there. And there's no GPS there underwater. How do you communicate? How do you understand about the position? Because the attenuation is very high, it's not possible for the electromagnetic radiation to go over there. So there is a depth reckoning is a position by which you calculate the current position, and as a moving object in relation to that, heading with the time and displacement with the time is the two principle we use in depth reckoning. This shows the 6 degrees of freedom. Any ship or underwater vehicle, these 6 degrees of freedom like a pitch, yaw, roll, that need to be taken into account while designing it and enhancing that. So we too have our own positioning system that is again interface to that. All these things are linked to the IoT and robotics technique. This is simple module control where DVL is the one which is a velocity log and depth sensor and a GPS system and acoustic positioning system. GPS is used when it pops up to the surface. Underwater, the acoustic system positioning system is used. This is just to show you a picture of how the acoustic position is done underwater, and when the system is deployed over there, it goes down, it starts communicating, and connection to the surface, then it forms. There are also these are all futuristic. People are working on it. Swarm requirement, a group of a swarm of AUVs can be dropped over there, and how they can maneuver and move along with that, and how the probability of finding the target. This you can see how the fishes, school of fishes, they move. Like you have school of means the batch of birds, they move it. So autonomy is the important thing here, which is having sense, interpret, and act upon unforeseen changes in the environment. So that level of intelligence should be there. So you must define the all the parameters, and you must have the all the aspects which can take place, and also the just have a framework of autonomy which can encompass intelligent decision making, system error handling, and intelligent intervention. So these are all something which need to be taken into account. In particular, energy management is one part of it. We normally don't exceed more than 80% of the total energy. We keep 20% as a reserve buoyancy, reserve energy, so that we can use it in case of emergency, so that we don't lose the system. In spite of that, many AUVs are lost, and they got buried on the seabed. So these are all the challenges we find in using in the ocean, which is highly expensive, exponential cost, specialized expertise is required. Going on board the ship is always difficult, and you have a time constraint and weather conditions. All together we work on it. This is in one of the British ship. Before they sail out, they have displayed what are the different type of what I told you, AUV and glider. They are all kept over there. They operate these gliders from the shore and deployed at different location and monitor this. You see, this is a level of robotics which has been brought in last 15 years. 15, 20 years ago when I was sailing, you don't find such type of robotic systems and underwater robotic systems. So now all those things control is possible now, and also to collect large amount of data sets. At present there are limitations, but in future these data sets will be freely available for user to do that. That's what in the international level, the international level, we are discussing with people. Unless you share the data and share the information, the prediction of understanding about the ocean will not be complete, as I shown it earlier. And to conclude, I thought I'll share with you. I was running the student autonomous underwater vehicle competition. This was instrumental by me, wherein the colleges have to develop their own AUV, and they will come and demonstrate this in NAOT. We had a various selection process with the national committee. We evaluate the student group comprising of mechanical, civil, electrical, electronics together, and with the model and their interest, and the college ready to fund. In the end, the successful selected teams will be asked to come to Chennai, either in a swimming pool or in IIT Madras or on a private. We used to make them to have a predefined path that is to follow. That winning team and the faculty teacher we used to send to San Diego, where in USA in July every year they conduct an international competition. I am very glad that I could pass through the procedural part of it and succeed. Initially, there are only 6 teams. In the end, when we stopped it in 2019, there are about 25 AUVs by different colleges. Now they are going themselves, they are participating in the Singapore AUV competition. This is what my small contribution in the field of underwater robotics. And there are also spin-off. One company which is running about $160 million funding in Chennai, part of IIT Madras startup. They are doing all underwater survey of bridges and also survey in Middle East. They have also developed AUV and supplied in Europe. And two more companies are there. I am also mentoring them personally out of interest, not any financial aspect related to that. These are different designs. These are all designed by student, and we don't own it, and they have to perform the duty. And they have also succeeded in some of the competitions in Europe and Singapore. The challenges there is buoyancy, waterproofing, selecting suitable hardwares, power management. Why we are teaching them is in underwater, the water ingression is the biggest challenge, and the battery management is the biggest challenge. You may have everything ready. When it comes to battery get drained, you have to wait for your turn. So we go with when you go out on board the ship, we plan from quarter pin to container. Everything we need to have a redundancy, because the ship cannot come back just because you don't have a battery. So that is the level of planning we do. And herein we are taught the students even in life how they need to plan. The IIT Bombay team had done a very good work. They reached up to some finals in the US, competing with about 56 AUs from different countries. In addition to that, the one of the student who was part of the team got a highest package that time in Microsoft, because Microsoft liked somebody working as a team and developing a product, and they interviewed him on this aspect than his subject what he has studied. That is the level of spin-off. This is what is a team. One of them, I don't know who is that. One of them got the job in Microsoft, and they are all doing very well in abroad and many other places. This is just show you how we started, how we have grown, and different 8, almost 9 colleges we have sent to USA, and they all are doing really very well. We do it in a systematic manner from NSTL Vizag. Dr. Manu, he used to be the chairman of the committee and he used to help. And this is the level of competition we used to conduct. And it was not funded by us, only travel we used to fund. That model worked very well in government system. This is to show you how there are also startup has come and how really useful. IIT Madras director was really appreciating me, saying that this is a level of, because IIT Kharagpur also the director said this is the biggest level of capacity development what you have done, and now they are doing self-sustaining. Last year I was invited by Echo magazine, UK based magazine, to write an invited article, editorial article, which is rare for an Indian to get that, where I wrote about sustained ocean observation for social benefit with my experience on conducting similar program for small island developing states. There are also video available related to this. Please Google, and this is a free journal available online. You can read it that. Another paper we published. I'm part of another marine mammal group. That work is also published in the same in another issue of this. So with this, I conclude the global change of change what we are finding on climate change and many other aspects. There is a newer thinking on prediction and also different aspects related to forewarning of the people. And now we have a big program WMO we call early warning for all is a big program. So for all these aspects, the data analysis interpretation using different models and also involvement of AI and ML and deep learning and IoT technique for measurements of data collection. All these aspects are required. So I'm sure that with this few 2.5 hours of our discussion, we're able to understand, and you will be able to read more papers and publications related to that and transfer this information to the students who come across. Definitely they would shine very well, because this also required not only this aspect, fisheries. Another important thing is that more society related, that oceanography and fisheries are linked to that. With this, I conclude. I wish to answer any questions what you ask. Thank you very much for your patient listening. Maybe Dr. Jaya, we can make them to come online so that one picture we can take. Sure, sure, fine, sure. Because if you ask questions only, I'll be able to answer more, or because my presentation was very confined. I did not want to tell too many things. because you are exposed to new discipline in a short span of time. Whereas discussion or questions from you can allow me to give more information related to that subject.
Sir, actually, your session is very clear, sir. We understood very well. Your research is very excellent, sir. So no
Thank you.
questions
Any...
means we learned a lot, sir. That's it.
Okay,
Thank you,
okay,
sir.
thank you.
Thank you very much for your nice session, sir.
Thank you. Thank you. We had a interesting workshop like this under the Indo-US collaboration. We had more than 35 students all over, scholars basically. We brought about 10 eminent experts. We call it as a Gurukul. Like we had ancient times or Vedic period, we had both a teacher and guru. They used to sit after the student has to live along with the teacher. Similar like that we have done, and up to evening 7, 8 o'clock, and the discussion had taken place on the modeling aspect. In the end, like this question and answer session came, and we brought a new idea called question bowl, where the student can put forward the question there, and the experts from US or anybody can answer to that, because sometimes students feel difficult to ask question. Very interesting questions were asked, like I told you earlier, Bay of Bengal is more freshwater influx, and stratification in Arabian Sea is more saline. And this question was, if that repeats, exchange each other, when West Coast become Bay of Bengal, East Coast become Arabian Sea, what will happen to the Indian condition? These are all something normally people don't like to ask in front of others. The question ball really helped. So maybe that idea also you can forward. Of course, we can always encourage students to come out to open up, but this one we found it much easier, and without name we were able to answer those questions. Because the days to come, it will be a citizen scientist. It's not that somebody who is defined or who is then the master or PhD only will be able to do the prediction. It will be simplified, like what we are seeing now, like R or these languages. When they come into the picture, definitely in use also what they have done. The 2 years, if the scientist can keep the data, after 2 years, because the money funding comes from the public, so they have decided to give these data sets for any other applications, like Google and Microsoft. They got large amount of data sets free of cost from US government. So maybe India also sooner or later such things would be there. Of course, now few scientists, they keep it. Mostly when I was working, our data sets, except strategic data sets, some of them like within the EEZ, I told you, exclusive economic zone, we are not supposed to transmit real-time temperature data. So that is not allowed. We don't do that. Whereas other data sets which are already transmitting in the real-time mode, like in GTS format, like meteorological data is allowed. It's allowed in the transfer to anybody else. So those things we transfer, but of course, again through a channel of Indian Meteorology Department only we do that. So this is possible in the days to come, which will be much easier once the barrier is broken. Even there could be app maybe down the line. One could be able to run his own way of prediction and say it could be an error, but at least for a common man, he gets a feel of it, what is to be there. So sooner, already we can see that 10-20 years ago, the ship captain who were not using mobile app for the navigation purpose. They used to have their own inherent experience, and they take a decision. Today, passengerweather.com is there. That will clearly say that which route he has to follow, and also often now is said that how much fuel you've saved. The ship owner will ask how much fuel it is saved, but that is nothing but if you follow certain ocean currents and wind pattern, definitely the fuel consumption is reduced. So that's mainly because they understand the knowledge how they should go along the coast or away from the coast, taking this aspect, not have a resistance to the wind pattern and things like that. So that is this passage with the .com is really useful, and they are also using the data sets like moved by what we are sharing with others. We found that they are using such interpretation. So that is one. And when I was in US, another interesting part is the ship captain in those days, maybe 200, 300 years ago, when the sailors used to come, they used to create a log. The log contains information like wind speed, current. It may be visual, but not much measurement. So when he was in US, one expert historian as well as oceanographer, they wanted to come to India, like in churches, like Portuguese, they have left these the log books in the churches. They are available there. They want to interpret, because after more than 100 years, there are not many data sets are there. But again, that has to be brought in, digitize it, and check it whether it's verified. It's a long drawn process. But this, he got a smaller funding for such aspects also. So there are newer thinking, newer requirements would come the days to come on climate part of it and prediction part, to have a better service to the society. These are all service to the society. Okay, science also is there, but the service component is major part.
Sir, good afternoon.
Yes, please.
Yeah, I am Durga Prasad from Baba Institute of Technology and Sciences. So we are really fortunate to have you, sir, in this session. And I really thank JNTU GV to have you as a resource person. Moreover, you are fortunate for our nation in the oceanography. And here I am working on actually security in addition with the deep learning.
Yeah.
So what sort of research could be done with in perspective of oceanography with deep learning and security aspects?
You have any specific work you are doing in security? You're using BRC? Are you working in BRC?
No. Baba Institute of Technology and Sciences.
Baba Institute of
Engineering
Technology.
college,
Okay.
sir, affiliated
Yeah, fine.
engineering college.
See what you can do. Basically, the one challenge you will find it. Some of the data sets are not freely available. So, for example, security related data sets, even if, for example, you want to know how much amount of some other, a ship has entered in our water, these data sets you may not find. What probably you can do, you can talk to Navy, or if they have information. One thing they would like to have is some of the things what they have got. How do you go for a prediction? If this incident, this has happened, whether this will happen later. It's not intruder part of it. Some activity what they have faced it, that is one thing. And so far is a channel which always they'll be interested. So far channel is a channel where the acoustic communication is different. You read about so far channel, whether the existing data sets can be used. Another thing you can work is with on AAS. Well, I also briefly mentioned about that. You can talk to port, automatic information service system. It's nothing but every ship more than 350 gross tonnage, you need to have AAS. These data sets are available. Where they are gone, where all the informations are stored. In addition to that, they are also supposed to transmit when they sail out the nearby ship. So they also have the data which ship is crossed over them, and this information is there. But at present, this is just used and left. But since you can handle AI and ML where large amount of data sets are there, you can look at the data, whether you will be able to clearly define how much amount of ship traffic is there and where they are. But also you can see global map of ship traffic. That's a course level you'll have. But a fine level, somebody wants to do something on the strategic part of in Vizag port, and that can be done. Maybe you can also talk to fishermen, collect raw data, mix to that. So that is the one thing I can say off the shelf without thinking. This is one simple work you can initiate that. One important thing, when you start working on it, you will find newer usage of one particular information for different applications. So that is the best part. But what you probably first point I always tell wherever I go in academic institution is that collect data. Unless you have the data in your hand, it will be very difficult for you to work on it. But this is one thing where you can talk to port authority or the ship owners to help you to provide AIS data. That there is the free data that's available with you, or you can also download. Some websites do have got AIS data sets. You can download and work on it.
Are there any instances of security compromises?
No,
in
I was
oceanographic
told
data?
unofficially, but I don't have any data set. That's what I'm telling. That
Okay.
information you have to personally talk to some people in Navy, and that has to be worked one to one.
Okay, sir. Thank you.
But you can show them, demonstrate. They may not be aware that you have the expertise. So you have to take an appointment and go there. For that, whatever I told you, free source data sets, you run a model. And even you have satellite imagery, you send a small region and show that this is what I have done. This will have an application provided I have a data sets.
Sure, sir.
Thank you. Good luck.
Thank you, sir. Thank you very much.
Currently, there are many data sets are there. Maybe you have to spend time. Some may not be raw data, but process data. But at least for you to get a feel of it, get into a newer discipline, if you put little more effort, you will get more data sets. And also start writing papers related to that. Somebody is interested, there is a ocean technology conferences coming up in Malaysia. I am also involved in that as one of the technical committee. I am a co-chair there. I myself have seen 1,200 papers. And this OTC comes, it's a biggest conference happening offshore industry part, mostly in Houston in USA. Once in 2 years, they come to Asia, and they are doing it in Malaysia. So that is the one thing where if somebody has a funding agency or somebody start working. So this type of AI and ML technique or activity or carbon storage they are talking about, I reviewed few papers, but there are few initial thinking over there, but I found that as a primitive. But this discipline is not fully utilized for AI and ML study. Maybe any one of you interested can start thinking in this direction. Yeah, we'll have fun. Okay, thank you. Thank you. Thanks a lot. Thanks everyone. Thank you. We'll keep in touch. Thank you. Okay. Thank you very much, Dr. Jaya. Thank you very much. Thank you. Yeah, I will come there. Your VC has been calling me. I'll come there. I have this UNESCO assignment. I'm busy in the evening time meetings. I'll try to come sometime. Thank you. Thank you very much. Thank you. Thanks for all your effort. Very short time. I wish to say that it happened in 2 days only. So you managed to push. And thank you very much. Thanks a lot.
Thank you, sir. Yeah. Okay, ma'am. Good evening to one and all. I would like to express our deepest gratitude and extend a heartfelt vote of thanks to our esteemed resource person, Dr. R. Venkatesan. Your presence here today has been nothing short of awe-inspiring. Your wealth of knowledge, exceptional expertise, and outstanding achievements have made this event truly extraordinary. Grateful for the invaluable insights you have shared with us. On behalf of JNTUG, I would like to extend our heartfelt thanks to Dr. R. Venkatesham for gracing us with his presence and enlightening us with his profound wisdom. Thank you, sir. And last but certainly not least, I would like to express our gratitude to each and every one of you, our esteemed audience. Your active participation, enthusiasm, and engagement have made this event truly memorable. Once again, I heartfelt thanks to each and everyone.
Madam, please provide the lecture links, madam. Is there any possibility? Madam? Thank you.
Any grading for how much we have to get the certificate? Is there anything to choose? Hello, ma'am. Yes, ma'am. Guess what? Is there any restriction on the grade to get the certificate, ma'am? Okay. Okay. Thank you.
Okay, ma'am.